Previously gathered evidence indicated that on the night of the accident, the three-man crew was in the process of connecting the control blades to the drive mechanism when the excursion occurred.
The excursion in question was a steam explosion that occurred near Idaho Falls, Idaho on January 3, 1961. The SL-1, or Stationary Low Power Reactor No. 1, an experimental nuclear power reactor developed by the United States Army, had destroyed itself in milliseconds. Investigators said it was human error. The Army said it was the messy result of a sordid love triangle. Conspiracy theorists said it was a murder-suicide. There is still some controversy about what happened that night to this day, but what is absolutely clear is that the reactor's only 3 operators had died with no warning and no witnesses, and it was someone's fault. This is the true story of America's first nuclear meltdown. The SL-1 reactor and the buildings that housed it were located at the National Reactor Testing Station, approximately 40 miles west of Idaho Falls, Idaho. Part of the Army nuclear power program, SL-1 was designed and prototyped on-site from 1957 to 1958 and became operational that December. Its goal was to prove that miniaturized nuclear reactors were viable for Army operations, able to provide electrical and heating power to remote locations like the Arctic. But SL-1 was just one reactor in the US military's ambitious plan to harness nuclear power in all its forms. In the August of 1958, a US Navy reactor developed at the testing station became the beating heart of the world's first nuclear submarine, the USS Nautilus, which used the relatively inexhaustible energy source to dive underneath the North Pole, putting all of the world's militaries on high alert. At the other end of the sprawling Idaho station, the US Air Force was rerouting hundreds of millions of dollars towards a nuclear-powered jet aircraft that could stay aloft more or less forever. The tiny SL-1 reactor, by contrast, the smallest in development, was not nearly as flashy and didn't get the attention or the funding that the promise of a nuclear jet or nuclear submarine commanded. What it did get, on the night of January 3, 1961, was the maintenance efforts of 3 young men. Army specialists Richard McKinley and John Burns, and Navy electrician first class Richard Legg. None of them were above 30 years old. John Burns was just 22. Trouble was already brewing years before the accident. John Burns and Richard Legg hated each other. They had gotten into drunken fistfights at prostitute-filled parties, and Legg had problems with authority. He had been caught sleeping in his car while on duty, he kicked his feet up on instrument panels, and he would set off alarms intentionally just to startle his crewmates. A month before the explosion, Legg showed up to work drunk. In the January of 1961, it was Richard McKinley's 3rd week on the job, and he was still learning the ropes, uncomfortable with all the readings and instruments. These were the men tasked with restarting a cold nuclear reactor containing 14 kilograms of uranium-235 on a frigid Idaho evening. Shut down for Christmas and New Year's, SL-1 was to be brought back to life by Burns, Legg, and McKinley on the 3rd day of 1961. The most important part of this process was lifting the central control rod manually just 4 inches to reconnect it to its drive mechanism. Burns, Legg's subordinate that night, prepared to lift the more than 80-pound rod with his bare hands while Legg stood with him at the top of the reactor. McKinley paced nearby. At 9:01 p.m., a reactor that was rated for 200 kilowatts of power generation spiked to 100,000 times that amount, 20 gigawatts, in just 4 milliseconds. The men didn't know it, but this minuscule moment, much faster than the blink of an eye, was the rest of their lives. Nuclear physics is hard, but how nuclear physics creates vast amounts of electricity is easy. Nuclear material naturally emits particles as it decays, which can impact other material and impart a tiny amount of energy as heat. If you put a bunch of nuclear material close together on purpose, as is the case in a nuclear reactor, radioactive decay will heat up other radioactive material, causing it to heat up and shoot out even more particles. Now we have a critical mass that will undergo a chain reaction all by itself. What stops this runaway reaction is other materials that get in the way, absorbing those particles. By moving these so-called control rods up and down in a nuclear reactor, you can precisely control how much heat is produced. Reactors then use this heat to turn water into steam and steam into electricity. If anything were to go really wrong at a nuclear power plant, control rods would probably be involved. The SL-1 nuclear reactor used water in two ways: as something to turn into steam, and as a fluid to slow down the neutrons, the particles that start and continue nuclear chain reactions, flying out from the fuel rods. You see, not every neutron has the right energy to continue a chain reaction. Faster neutrons are actually worse than slower neutrons inside of a reactor, and so water, a very dense fluid, can act as a so-called moderator to help continue the heat production by slowing down particles. What's more, the water in a reactor like SL-1 can act like a failsafe. If too much heat is generated, water molecules move apart and expand into steam inside of the reactor. Now there are voids and less water to moderate, too many fast neutrons are flying around, and the number of fissions decrease drastically. The reactor gets cooler and safer on the path towards shutdown. In the interest of simplicity and reducing size, SL-1 only had 5 control rods. As a comparison, the Chernobyl reactor number 4 had 211. Because of the small number of control rods and their orientation inside of SL-1, the center control rod was immensely powerful. Moving it could drastically change the amount of radioactivity in the vessel. Shove the central rod number 9 all the way to the bottom of the reactor, and it would shut any reaction down. And pull it all the way up, and it could start up the reactor all by itself. Make no mistake, building a prototype reactor like this was inherently less safe than other larger reactors. Most of these larger reactors followed a design protocol that held that no single control rod should be this powerful, should be able to shut down or start up a reactor all by itself, as it would take just one stuck rod to create a deadly situation. As fate would have it, the control rods inside of SL-1 had a habit of getting stuck. Between February of 1959 and December of 1960, the 5 control rods malfunctioned a total of 63 separate times. The central control rod had malfunctioned 7 times. In response, the Army told its operators to exercise the rods, regularly move them up and down to prevent them from sticking in the future. But the rods weren't the only problem. All the way up until 1961, corrosion inside SL-1 was building up, bearings were wearing down, rods were getting misaligned. 15 days before the accident, 2 of the rods inside of SL-1 had to be hit with pipe wrenches in order to work them loose. On the night of January 3rd, John Burns was leaning over a demonstrably unreliable control rod number 9, preparing to lift it just a few inches as a part of routine maintenance. Richard Legg was watching over his shoulder. Richard McKinley was standing just a few feet away. At least, this was where their corpses suggested they were. The difference between a nuclear reactor and a nuclear bomb can be as simple as the speed of neutrons. When a large nucleus gets cleaved in two during a fission event, there are 2 kinds of neutrons that fly out. The first are so-called prompt neutrons, which are the particles that are launched outwards in less than 100 trillionth of a second. The second kind of neutrons are the delayed neutrons, which are produced by fission products a few fractions of a second later. Nuclear reactors take advantage of delayed neutrons in order to control the energy released. Nuclear weapons, on the other hand, want to produce as many prompt neutrons as possible, creating an avalanche of additional fissions that release energy as quickly as possible. When a reaction like this kicks off, it's unsurprisingly called going prompt critical, and it's a condition that would be an absolute disaster inside of a sealed reactor. Water and nuclear material would instantly vaporize, circumventing the natural failsafe of a water-moderated vessel, and create a situation closer to a nuclear bomb than to a source of electricity. At 7 p.m., John Burns got a phone call. It was his wife, Arlene, calling the SL-1 facility to ask John for a divorce. According to Todd Tucker in his book on the subject, Atomic America, John and Arlene's last conversation ended with a discussion of how to split his paycheck. John would hang up the phone, exhausted, having slept on a friend's couch the last 2 nights. And because of his frequent headbutting with the powers that be at the National Reactor Testing Station, he was now personally and professionally stuck with the unglamorous, unloved SL-1 reactor. This was all going on simultaneously in the mind of a man who at 9 p.m. that night finally reached the point in his long list of duties that involved moving the central control rod of SL-1. With his supervisor, Leg, literally breathing down his neck and a soon-to-be over marriage surely clouding his mind, Burns hunched over the almost 100-pound rod, a rod that often got stuck, a rod that could start the reactor all by itself if handled improperly, and prepared to move it just 4 inches upward and no further. Operators of SL-1 knew what would happen if you lost focus and pulled the central control rod up too far. According to Susan M. Stacy in Proving the Principle, when asked whether or not the operators knew the reactor would go prompt critical if the central control rod were fully removed, one responded, quote, "Of course. We often talked about what we would do if we were at a radar station and the Russians came. We'd yank it out." End quote. In other words, improperly removing the central control rod would immediately kill everyone in the building. Just 60 seconds later, at 9:01 p.m., this is exactly what happened. As the report completed years later would conclude, Burns withdrew the central control rod many inches too far, and just 4 milliseconds later, a power surge of 10 million% above normal operation explosively vaporized the core of SL-1. Cooling water was blasted upwards by this vaporized fuel and struck the top of the vessel with an extreme amount of momentum, enough to lift the entire 26,000-pound apparatus over 9 feet into the air. The plugs at the top of the reactor were forced open by the over 500 pounds per square inch of pressure, and the control rods were fired, like missiles, at the ceiling. The entire reactor room was instantly filled with burning steam, contaminated water, and fragments of the radioactive core. SL-1 had just gone prompt critical. Later experiments would show that the explosion that night was the equivalent of 32 kilograms of TNT. And all that energy was released directly into the bodies of Legg, McKinley, and Burns. There was no one else in the building. Long, short. This was the sequence of alarm bells that told the firefighters 8 miles away that something at the SL-1 site was wrong. Heat sensors had been tripped above the reactor. But the 6-person team on the way wasn't particularly worried. They had already responded to not 1, but 2 false alarms at the site earlier that same day. So when they got to the building's unguarded gate at 9:10 p.m., they were expecting another non-incident. What they were not expecting was that the radiation detectors were blaring. 7 minutes later, at 9:17 p.m., a health physicist and a fireman donned masks and air tanks and approached the reactor building stairs. Halfway up, the radiation detectors started ticking, and ticking fast. They retreated down the stairs for another detector. Theirs must have been broken, they thought. There was no way radiation levels inside were that high. They returned and found the same worrying readings, but this time they took a look into the reactor room. The operators were nowhere to be found. With enough radiation around them to be dangerously dosing them in minutes, the men again retreated. Emergency crews didn't enter the building for over an hour. The radiation levels were high enough that a plan had to be formulated first. So at 10:45 p.m., it was decided that only 1 entry into the building was allowed per person, and that entry was limited to just 60 seconds. When the first team of 5 men entered the building, they found 2 heavily mutilated men. Burns was dead. McKinley was moaning nearby. Both were soaking wet with irradiated water. Both were removed by stretcher and by the same ambulance. 15 minutes later, however, McKinley was dead. 2 of SL-1's 3 operators were accounted for. The third was discovered last because he was barely recognizable. Shaken men reported back at 11:38 p.m. after the latest pass through the destroyed site. They had seen something stuck to the ceiling, a lifeless clump they initially thought was a bundle of rags. It was the body of Richard Legg. Rod number 7 had been launched from the reactor vessel like a rocket and impaled him through his groin and shoulder to the top of the building. While the body of John Burns and Richard McKinley were easily removed, the body of Richard Legg posed a problem. It was pinned by control rod 7 directly above the now obliterated reactor core. emergency crews were worried that Legg's body might fall back into the reactor core during retrieval, and if it was covered in enough radioactive material, or if Control Rod 7 still had enough fuel in it, it might cause the reactor to go critical a second time. So, while the bodies of Burns and McKinley were taken by ambulance to the nearby chemical processing plant, a makeshift hot room for the corpses on the night of January 3rd, it would be almost a week before Legg's body would join theirs. On January 9th, a team of 10 men used sharp hooks on long poles to pull Legg's body free from the control rod piercing it. It dropped onto this stretcher, attached to a crane leaning in from outside the building. The explosion of SL-1 remains the only fatal reactor accident in United States history. At the time of the accident, there was maybe only a single man on Earth who had performed an autopsy on a radioactive corpse. That man was Dr. Clarence Lushbaugh. Almost exactly 2 years before SL-1 exploded, Dr. Lushbaugh had put a man named Cecil Kelly's brain in a mayonnaise jar and sent 8 pounds of his tissues around the country after Kelly died in a criticality accident at Los Alamos National Laboratory. But that's a longer story for another time. Dr. Lushbaugh boarded a military DC-3 in Los Alamos at 2:30 p.m. on January 8, 1961, and arrived in Idaho 4 hours later. Reportedly, officials in Idaho were grateful for his availability. When Lushbaugh and his team arrived, they found 3 bodies waiting for them inside of the decontamination room of the Idaho Chemical Processing Plant, an improvised hot room after SL-1 exploded. The remains of Burns and McKinley were in stainless steel tanks filled with alcohol and ice for preservation, and Legg was still in the lead cask he was placed inside after descending from the ceiling. His body was far too radioactive to be in the open air. To process these bodies, Dr. Lushbaugh's team would have to get creative. Each body was heavily mutilated and so radioactive that it wouldn't be safe to be in the same room with them. According to the actual transcript of Lushbaugh's original autopsy report, quote, "Since bodies emanating such high levels of radioactivity had never been encountered previously, modifications of the usual autopsy procedures and techniques had to be improvised upon the basis of radiologic safety procedures and common sense. The personnel who made these examinations comprised a well-trained team of 5 health physicists, 1 radiobiologist, 1 pathologist, and 2 physicians." End quote. An improvised autopsy table was created from sawhorses and a stainless steel tray. Knives, hooks, and hacksaws were attached onto lengths of galvanized steel pipes by a nearby welding shop. The team wouldn't be able to get anywhere near the bodies with parts of them as radioactive as they were, so Lushbaugh cut them off. Quote, "Legg's head, which appeared to be the major source of the prohibitive radiation level, had been damaged by the blast beyond recognition. There could be seen some obvious cervical fractures, which appeared to make feasible the separation of the head from the body. This operation was then carried out with a specially prepared knife, long-handled hook, and wire snare controlled through a 10-foot pipe handle. The remains of the head were placed in a lead cave 20 feet from the cask." End quote. Again, according to the 1968 book Atomic America by Todd Tucker, large chunks of Burns, Legg, and McKinley were, quote, "sliced, sawed, and hacked off by Lushbaugh, and then placed in a drum and buried in the Idaho desert as radioactive waste." End quote. Rushed by radiation, each autopsy only took Lushbaugh between 15 and 20 minutes. Dr. Lushbaugh determined the cause of death for each man. Richard McKinley bled out after his hand and the right side of his face was blown off during the explosion. John Burns, quote, "died the instant he struck a flat surface that fractured his chest and drove a rib through his heart." And Richard Legg, quote, "died instantaneously from the destruction of his viscera by rapidly expanding gases that penetrated his abdominal cavity along with a heavy missile." In examining the bodies, Lushbaugh was able to place the men the instant before SL-1 went prompt critical. This answered the question of how, but not the question of why. Why did John Burns remove the rod like he did that night? Was it an accident, a suicide, or something else? Thankfully, most of the radiation released by the SL-1 explosion was contained inside the building. This allowed the General Electric Corporation to remove the reactor vessel and clean the contaminated buildings from 1961 to 1962. On May 21, 1961, GE constructed a burial ground 1,600 feet northeast of the original site of the reactor and sealed 99,000 cubic feet of contaminated material underground. The bodies of McKinley, Burns, and Legg were not returned to their families. They were instead placed in lead-lined caskets inside of metal vaults and covered with concrete. Richard McKinley, John Burns, and Richard Legg had died during America's first nuclear meltdown on a frigid night in rural Idaho. There were no witnesses. Based on the circumstantial evidence, it was either an accident, suicide, or murder. It's not surprising that the story of an unstable John Burns, just off the phone with his now ex-wife who is possibly having an affair with Richard Legg, committing a murder-suicide with a prototype nuclear reactor, is the story that gets retold the most often. And you'd be hard-pressed to find any retelling of the story of SL-1 that didn't include these details. However, according to the final report, which took almost 2 years to complete and involved literally hundreds of scientists, experts, and engineers from a dozen different research and government entities, no evidence of a love triangle or murder-suicide was ever found. The best explanation, as mock-ups and experiments testing every aspect of that night demonstrated, was that the central control rod number 9 was likely stuck, as it had been stuck many times before, and Burns pulled the rod up too far while attempting to free it. This wasn't anywhere near as exciting as a jilted lover bent on nuclear revenge, but it was no less damning for the military. The SL-1 reactor was in a terrible state before it exploded. It was literally falling apart and looked after by young men whose total experience could be measured in months. As Todd Tucker asks in Atomic America, quote, "Why would a reactor be designed so perilously close to criticality? Why would procedures actually dictate the manual lifting of that rod? Why was Burns allowed to perform dangerous maintenance with so little supervision?"
Direct cause of the accident clearly appears to have been manual withdrawal of the central control rod blade by one or more of the crew members considerably beyond the limits specified in maintenance procedure. However, there was insufficient evidence to establish the actual reason for such abnormal withdrawal.
The Army's hope for a miniaturized nuclear reactor had died with the men tasked with operating it. Rather than revolutionize power generation in remote areas, the meltdown of SL-1 solidified a safety criterion for all future nuclear reactors built in the United States. No reactor after SL-1 would be constructed in a geometry that would allow for just one stuck rod to force it into criticality. 2 decades later, the world would experience the worst nuclear disaster in history. Chernobyl reactor number 4 would melt down and end up contaminating an area that was the size of countries. This meltdown was far worse than anything that ever happened in Idaho, but interestingly, it was also the result of improperly withdrawn control rods, also during the maintenance of a shutdown reactor, and also overseen by a small, unsupervised crew in the middle of the night. When we don't learn from history, it tends to repeat itself. Until next time. Thank you so much to the very nerdy staff at the facility for their direct and substantial support in the creation of this here video. Today especially, I want to recognize Research Assistant Joe James and Visiting Scholar Michael Sontag. If you want to join the facility, if you want to join me and the over 1,500 staff members that are draping on silky white lab coats, getting episodes early, getting members-only live streams with me, not like that. You can go to patreon.com/Kyle Hill and sign up for the facility today. And hey, if you support us just enough, get your name on RA here each and every week. And as you can see, there's literally over 1,000 of you. So I have no idea how I'm going to pass it. Yeah, quite a transition, huh? Going from that narration to looking at me. Anyway, it's quite telling to me that the story about the sordid love triangle and the murder-suicide is the one that's retold most often when you hear about SL-1. I think it speaks to our desire to have some reckless human element as part of the story, but it turns out there's no evidence for that, and it really just came down to poor supervision, poor maintenance, poor engineering, and it's not quite as sexy, but it still teaches us something. And no matter what our brains want from us, we have to go where the facts tell us to go. Think about that. Thanks for watching.